We're going to talk about the Simplex method. We're going to discuss standard maximization problems. So we have a standard maximization problem if we have these criteria. The objective function is maximized. All variables in the problem are non-negative, and each constraint can be written so that the expression containing the variables is less than or equal to a non-negative constant. And then here is the Simplex method. So we're going to work a problem. I'm actually going to give you the pieces of the method as we need them. So we're going to solve the linear programming problem here using the Simplex method. So we have maximize p equals negative x plus y plus 2z, and it's subject to these constraints. 3x plus 4y minus 3z is less than or equal to 23. 5x minus 4y minus 3z is less than or equal to 10. 7x plus 4y plus 11z is less than or equal to 30. X is greater than or equal to 0. Y is greater than or equal to 0. Z is greater than or equal to 0. Before we get too excited, we have to verify that we have a standard maximization problem in order to use this process. So, is the objective function maximized? Well, let's make sure we know where the objective function is. This is the objective function. Okay, we see yes, it is maximized. Yes. And it says, are all variables in the problem non-negative? We'll look at x greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0. Remember, we classify numbers three ways according to sign: positive, 0, and negative. So if something is not negative, it's 0 or positive. These right here, these tell us the variables are non-negative. So yes, we're good. Okay, and then it said, can each constraint, so where are the constraints? This is the part that we're going to call constraints. So, can each constraint be written so that the expression containing the variables is less than or equal to a non-negative constant? So, the way I like to think about that is, I like to say that anything with a variable, so a sum and or difference of variable terms, is less than or equal to a non-negative constant. So, less than or equal to 0 or a positive number, either one. So look up here. Sums and or differences of variables less than or equal to a number here that's positive or 0. And I have that. Be very careful. This doesn't say that I can't have negatives. This said the constant cannot be negative. So this one is satisfied. So it turns out this is what we call a standard maximization problem. We have satisfied those criteria. So we're going to create our Simplex Tableau. The first thing we're going to do is create something called slack variables. We are going to look at the constraints. Okay, the constraints are going to be the ones that get slack variables. Okay, well, what do you notice about the constraints? Look at everything else in here. The constraints have an expression compared to 0 or a positive number, right? So we are really going to put this into a matrix. It's called an initial simplex tableau, but it's really a matrix. Think about when you did matrix operations in the previous sections. You had equations, right? Didn't you take an equation and put that into a matrix as a row? So we had to have equal signs. So if you look at these constraints, they don't have equal signs. So we're going to have to adjust them somehow to make them have equal signs. So we're going to introduce a new variable to take up the slack. Okay? So we're going to just practice. We're going to kind of talk this out. Let me just scroll down here. This is going to be like our scratch work. I'm going to do it right here. Scratch. Okay, let's just look at the constraint, the first constraint. Constraint 1. Constraint number 1 was 3x plus 4y minus 3z is less than or equal to 23. So we're just going to look at that. This has nothing to do with our answer to our problem. We're just sort of talking it out, trying to introduce what slack variables mean. Okay, but I initially have an inequality. I know I need an equation. I need an equal sign. So I need to add a variable to pick up the slack. So we are just going to pull some numbers out of the air. We're going to suppose, again, this is not the answer to my problem. I just pulled out these problems and numbers just to see what we're working with. Suppose x equal 3, y equal, I don't know, 4, and maybe z equal 5. I pulled these out of the air. These have nothing to do with the answer to the problem. And if I plug these in, what happens to that constraint? Okay, so I have 3 times x. Well, my x I said was 3. Plus 4 times y. Well, y is 4. Minus 3 times 5. So all I've done is taken this x, this y, and this z value, and I've plugged it in to the left-hand side of my inequality. This expression right here. Okay? And therefore, it's still less than or equal to 23. So 3 times 3 is 9. 4 times 4 is 16 minus 15. Okay? Well, is that less than or equal to 23? 9 plus 16 minus 15, isn't that 10? Is 10 less than or equal to 23? We know it is, right? Okay, so how do you change this inequality to an equation? What can I add right here to make that an equal sign, equals 23? Well, I could add 13, right? So what I'm doing is I'm going to replace this inequality right here. Okay, now I pulled numbers out of the air, right? I could have picked lots of different choices for x, y, and z. For example, let's just do another one. What if I chose, suppose x is 1, y is 0, and z is 1. I just pull these out of the air. So 3 times 1 plus 4 times 0 minus 3 times 1 is less than or equal to 23. All I've done is plugged in x is 1, y is 0, z is 1. Well, if you do that, what do we get? You get 3 plus 0 minus 3 is less than or equal to 23. We'll simplify that. Don't we get 0? 0 less than or equal to 23, but I need an equation. So 0 plus what gives me equal to 23? I would add 23. So I've replaced that inequality with plus some number equals. Well, it says introduce slack variables. Variables vary, right? They're able to vary. It's a number I plug in that can change. So if I pick different values of x's and y's, I just showed you two cases here, different values of x's and y's, that's going to change what number I have to put here to pick up the slack. So we're going to write that as a slack variable. Okay, so we're going to take our constraints. Our constraints were 3x plus 4y minus 3z less than or equal to 23. And we're going to replace that inequality with something else. 3x plus 4y minus 3z with a variable. But let's pick a variable that maybe helps us remember it's a slack variable. Plus slack variable 1 equals 23. Okay? Now let's look at the second constraint. 5x minus 4y minus 3z less than or equal to 10. Again, I'm going to replace this inequality with adding some number and an equal sign. So I'm going to get 5x minus 4y minus 3z plus a slack variable, but it doesn't have to be the same number as the first one. So I'm going to introduce a different slack variable, s2 equals 10. And I take the third constraint, 11z, less than or equal to 30. So I'm going to replace this inequality with plus some slack variable equals. But again, it could be different than the other two. So you notice I've replaced less than or equal to with plus s1 equals, plus s2 equals, plus s3 equals. Okay, so now I've created my slack variables. Part A is done. 1b, rewrite the objective function so that the coefficient of p is 1 and all variables in p are on the same side of the equal sign. Okay, so let's go back to the objective function. I've labeled it for you up here. Objective function, we want the coefficient of p to be 1. But what is the coefficient of p? Isn't it 1? Okay, the coefficient of p is already 1, okay, but I need all the other variables in p to be on the same side. So that means I leave p where it is, and that means I have to move these variables. I have P equals negative X plus Y plus 2Z. I'm going to move all of these this way. So if I'm going to move them, I'm going to add X to both sides, right? I'm going to subtract Y from both sides, right? And then I'm also going to subtract 2Z from both sides. So when I do that, you see this will cancel, this will cancel, this will cancel. Right-hand side is going to be 0. But then I'm going to have an X minus Y minus 2Z plus P equals 0. And check it. I move the X over so I get a positive X. Move the Y over, it becomes a negative Y. Move the 2Z, it becomes a negative 2Z. Do we see this? So this is the new objective function. This guy is going to go in the simplex table. Okay, so let's put it together. We're going to write down all the variables that we have, okay? So I'm just going to rewrite the objective function. This was the objective function. X minus Y minus 2Z plus P equals 0. So we're going to put those four things into a matrix, pretty much. Okay, so how many variables do we have? Well, we have X, we have Y, and we have Z, and we have P. We had those to begin with. But remember, we also introduced some more variables. We have the slack variables, so we have to make sure we have columns for them. So we have an X column, we have a Y column, we have a Z column. We'll have an S1, an S2, an S3 column. Those are new. That's from these guys. Okay, and a P column. And then we will have our constant column. So we just take our equations and put them in as a row of the new table. So 3, 4, negative 3. S1 has a coefficient of 1. Notice, in this equation right here, there's no S2, no S3, and no P. So we're going to put 0 as a placeholder. And 23 is our constant. Do the same thing with the second equation. 5, negative 4, negative 3. There's not an S1, so 0. 1, 0, 0, 10. 7, 4, 11, 0, 0, 1, 0, 30. That's all of the constraints. So we draw a line down here and we put the objective function. 1, negative 1, negative 2, 0, 0, 0, 1, 0. Okay? Sometimes you'll put brackets around it like this, maybe not. And notice when we're done, the slack variables in P will have something that looks very similar to an identity matrix. Okay, so this is the initial simplex table, Tableau.